Hi, this is Sanjeet, and today I am going to give the architectural presentation on one of the use case which I have completed for one of the leading pest control customer. The name of the customer is ABC. ABC is the manufacturer and expert in pest control. They are committed to provide practical, valuable advice and solution for an effective pest management to their customer. They have the existing PDA solution which is used by the field technician to provide effective pest management solution to their customer base. However, this PDA solution having a point-to-point integration with different backend system, including high level of manual process. And also the current pain areas are like asynchronous data processing, no high availability, and also whenever there is a plant downtime, the technicians are badly impacted. If we look at the functional area of the business solution for the ABC, then they are looking for a complete automated solution for the technician, which can be used by technician to complete the visit and also generate the proof of service, which is also called a service receipt, and then send to the end customer. To achieve this, they have built a lightweight mobile application which can be installed in any Android mobile, and then they are looking for an integration of the mobile device to their backend system to perform day-to-day work. They also have a requirement to keep the proof of service, which is a service receipt which will be completed end of visit by the technician in the cloud storage like Amazon S3, so that only the actual URL or absolute URL will be saved in the backend system as part of the proof of service. So the main point on the business functional area are like start and end day to allow the start and end time of the technician. Work view will allow technician to view how many work are assigned to the technician, and start and end visit will allow the technician to record the start and end time of the visit. And proof of service is a service receipt which has to be saved once the work is completed or the visit is completed by the technician. Here is the current solution in place in ABC, where all the technician PDAs are tightly coupled with the end system, which is a bespoke master system. And on the diagram, we can see ABC data center. And in ABC data center, they have different master system per country. And these tightly coupled integration is done in such a way where what is happening behind the scene, like what data is coming out of the system, how what data is processed to the system, is really difficult to see and monitor. And also if there is a downtime, which we have already discussed in the last slide, then uh, even if it is a plant downtime, then the technicians are badly impacted. To get the benefit and to overcome from this problem, we have used MuleSoft, where we can see the list of component and their benefits from this diagram. So first is Anypoint Design Center, where we have Studio, Anypoint Designer, and Connector Dev Kit. So Anypoint Studio is a unified graphical design environment for Anypoint platform, which accelerate developer productivity with an easy API development. API Designer. API Designer is a graphical syntax-aware platform to design and document APIs (RAML). Using this, we can also share the API design, test it using API mocks, and create interactive example using API notebook. Connector Dev Kit is a MuleSoft software development kit for building reusable connector for any system. It is fully integrated with Anypoint Studio, so anything you develop can be packaged, installed, and reused. The another component we have is Anypoint Exchange, and Anypoint Exchange is a home to the complete listing of connector template examples of APIs. Exchange can also be used by an organization to keep private assets and internal best practices which can be shared within organization. The third component we have is Anypoint Management Center, where we have API Manager, Runtime Manager, and Analytics. So this API Manager is used for proxy, manage, and govern APIs. API Manager provides security and resilience that ensure the performance without compromise the control. Mule has an auto discovery component. So if you develop any application using auto discovery component, it will be auto added or auto discovered in an API manager. So in this case, you don't need to go and add those API in API manager to enforce the policies. The runtime manager provides a single view of everything occurring across Anypoint platform, on-premise or in the cloud. They also provide full management, deployment, and undeployment of the APIs across multiple Mule environments. Analytics. Anypoint Analytics is used to get full visibility into API matrices, message traffics, and backend integrations. It provides information how your API and integrations are being used to inform forward-looking design decision. Customizable dashboard provide real-time views of API consumption trends and operational performance to access how they are performing against SLAs. We have API portal, where this API portal is used to generate documentation automatically from an API specification. It provides different theme to match organizational branding. It also provides SDK to support to different languages. And Anypoint Connector facilitates every integration of your Mule application with third-party APIs and standard with a standard integration protocols. MuleSoft has different levels of connector like select connectors, premium connector, community connector, which we can use where they have different support uh, levels. So if we see these benefits and how can we get the most from this MuleSoft benefits is like we can use this Anypoint Design Center to develop all the flows, and this Anypoint Exchange can be used to keep all the assets like whatever templates, connectors, or APIs are developed that will be kept under Exchange. And API portal, all the portal will be linked with the Exchange. So any consumer, if they want to see what are the APIs are available, what are the request and response payloads are there, what are the error descriptions or a set of error messages are set up for an API, those details can be found from API portal. And connector, like for our use case, we are going to use Amazon S3 connector, which is one of the select connector from MuleSoft that can be used to integrate with Amazon S3 to create a binary file, to download binary file, and to delete binary file. Here is the solution architecture overview of for the ABC, and it is for on-prem, where we have one Mule platform, ESP runtime, and we have one API gateway, and these two platforms, API gateway and ESP runtime, are managed and monitored using MMC. We have a Mule Anypoint platform, where the APIs are the APIs which are deployed in API gateway are auto exposed or auto discovered in Anypoint platform, where API manager is available to enforce or manage all the policies to the APIs. And also here we have Amazon S3. So the basic requirement for ABC was to identify the technician, whether the technician belongs to UK country or Ireland or New Zealand, because here in ABC data center they have their own country-based master system. So if the technician is working for UK, and if he is working for a business line like Pest, then based on that logic, we as an ESP or MuleSoft, we have to identify to which end system we have to redirect the call. So we have written a custom policy under API Manager with the help of Mule Anypoint platform, where we have a custom policy which will validate whether the country and the business line is valid or not. And if it is valid, then only it will proceed for further process to gateway and then platform, and then it will reach to the end system. If at the first place, if it is identified that the technician is not having a correct country code or a business code, then those requests will be redirected directly to the consumer with a failed response. And also when the request is completed or the visit is completed by the technician, those messages will go to the end system and it will be uploaded into Amazon S3 as a proof of service. And also at a real runtime, it will go to the end customer using Amazon SES to send an email to the end customer, and also the notification will be received and it will be saved in the bespoke master systems. Here you can see we have also built an automated incident management component, and this component is a generic component that can be hooked to any Mule application. So let's discuss on this component also, because this is a kind of a component which will really add a value to the operations team. Here, this is the component where you can see it is built for on-prem to automate the incident management, where these are the client, where these clients are the Mule application, which integrates to the audit and logging common component. And this login common component is internally integrated with the JMS topic. So every time whenever the client or the Mule application receive any request, and if it is processed the response back to the consumer, those request and response will be stored under JMS topic. And there are two subscribers which subscribe to the same topic to get the messages, and it will be written under Mule application log and the audit database. And this audit database is integrated with the Splunk to get the dashboard related data. And also this JMS topic is integrated with MuleSoft own connector, where we have ServiceNow connector to integrate with the incident management system. And it is having a quad scheduler which is keep on checking in every 2 or 3 hours to see if any error messages are stored under JMS topic. If there are multiple errors are available, it goes and create a single incident in ServiceNow, which is automatically assigned to a ESP support team. So this component is a generic component that can be used in any application across any clients. Here's the integration architecture where we have used Mule API led approach. So if you see here, this API led approach where we can see the system API, we have first layer, and then second layer we have process, and then experience layer. So the system API are those API which extract the sensitive information from your system. For example, if you have a Salesforce, if you have a SAP, or if you have a any legacy system, so all these system has their own API. Those APIs are system APIs, or we can say those are native applications or native API developed or built by system. So that's the reason this is called as a system API. Whereas process API are designed specially for processing in an organization. For example, if you need to fetch your bank balance from smartphone or laptop, the process is the same. And in the experience API, this experience API would be developed according to how the information is displayed on any particular device. For example, if you want to see your information from the backend system in JSON format, because if you are a user, you may not be able to identify how the data is transferred from the end system to your system. But if you are a technical user, then you will be able to understand that your device, your smartphone is pulling the data in JSON format. Maybe if you want to see the same data in web application, then the web application is trying to pull the same data from the end system in an XML format. So these experience API will be used not only to change based on the consumer requirement, but also this experience API can be controlled based on the throttling. If the number of requests are more, we can throttle. And also there are a lot of existing or out of box policies are available in any point API manager that can be enforced to your experience API based on different SLAs. Out of box, you can integrate with LDAP. You can authenticate user using open authentication. Also, you can enforce client ID enforcement, where you can ask client to pass the username or the password, which will be validated, and it will also add as a reporting where you can identify, okay, this API is consumed by these many consumer. So if you allocate the consumer ID or a client ID to every client, you will be able to see the reporting using API analytics. So the first use case you can see here is to get work from the end system. So get work is having an experience API, and we have identified that to get the work for a technician from the end system, we have to go with two different system API. So first we need to call get employee. Once the employee is identified as an active employee, we will be able to pull the get work from the bespoke master system. And this will go to the process API, which is a get work process API, and then it will again return all these detail to the experience API, which will return the data to the device in JSON format. The second use case we have is to complete the work or end work from the mobile device. So whenever technician completes the work, they will get the customer signature, and that signature will have to be saved in Amazon S3. So here you can see the integration is done based on multiple system API, which completes the work in the end system, upload the service receipt or proof of service binary detail to Amazon S3 using upload binary system API. And once the binary is uploaded, it goes to the end system and update the service receipt URL, and also it sends email to the end customer using Amazon Web Service. So all these system API are orchestrated in at the process API, and the end work process API is created, and on top of that we have experience API, which returns the data to the technician or to the consumer in JSON format. Also, the third use case we have, or the third API we have, is get service receipt. So here there was a requirement to build a service that can pull the service receipt from the Amazon. So this can go to first to the process API and system API, but here you cannot see the process API because we can directly connect to the system API, because sometimes it depends on the requirement where you really need a process API where multiple system is orchestrated or system APIs are orchestrated. But it all depends on your organization, if they are okay to pass this information from the experience to the process API, because most of the time your experience API are hosted at in the API gateway layer, which is normally be installed in gateway, which is a DMZ location. So it depends if the organization are okay to pass those information and pull the information directly from the system API, then we can go ahead and use those information and process through experience to the consumer. Deployment architecture. So here, as the ABC is using a full on-prem solution or on-prem architecture or infrastructure, we have this deployment architecture where we have a Mule ESB platform under LAN, and then we have API gateway, and these two are managed by MMC, where you can see here. And these API gateway server are exposed over internet using external load balancer. So whenever request comes from the outer world or from the client, it goes to the external load balancer, then it will be redirected to node 1 and node 2, and from the node 1 and node 2 of API gateway, again it redirects to the internal load balancer, and then again it goes to the node 1 and node 2 of ESP, and then ESP will connect to the end system, then get the final result, and then it will be returned back to the consumer. So here the API, whatever is deployed in API gateway, is managed by API management console. So all the APIs are enforced with the policies using API management console, whereas MMC is used for deployment or undeployment or manage monitor all these servers, including API gateway and MuleSoft servers. On the deployment approach, as there are different deployment approach are available, like project led or platform led. So first we have decided to use a project led, but project led was the most common approach we have observed, where many customer focus is too much on the project execution and delivery and never be able to devote the time and resources to maturing their platform capability. Whereas platform led, some customer took a platform led approach and committed a general built out of mature architecture with a canonical model and share services and APIs. But they do not do this at the expense of delivering project that the business recognize as a valuable. However, this project is attractive in theory, but in reality, before IT can prove the value of their platform, the business begins to question the investment, and you may never get there. So we have decided to go with a balanced deployment, where the most successful model we have observed between project and the platform led is the balanced deployment approach, where specific platform development objectives are defined within projects that are valued by the business. They prioritize project, then align well with the platform goals. So we have decided to go with the balanced deployment approach for ABC. So enabling the composable enterprise. So till now we have discussed on the technology, we have discussed on the API-led connectivity. Now we are going to discuss on the center for enablement, where these three components, technology, API-led connectivity, and the center for enablement, combines to build a hybrid integration platform. So hybrid integration platform is not only about technology. It involves architectural approach and people process, which is usually the hardest part. So here is this C4E, where it says like it's a center for enablement. So the center for enablement is a new operating model for IT. It enables IT and business unit to fulfill connectivity needs through an API-led approach, and it is not a project delivery team. Its primarily for purpose is to enablement of project delivery team to leverage the platform and work in a faster, more agile and scalable manner, whilst also driving reuse and mass adoption. So let's go with an example for C4E. We have different components listed here, like technology platform, architecture, governance, monitoring, service ownership, enablement. So this C4E is basically used to govern or monitor or manage all the APIs which are developed in an organization. So if we go with an example, let's say ABC is our customer, and we are going to develop APIs for them. So if we build a set of API for an organization, then those API will be hosted or published in an exchange or in a portal, and those API will be managed or governed by C4E. So in future, if any other vendor comes for the another implementation for the same customer, then this C4E will enforce them to go and see what are the APIs are already available in the exchange, so that they can reuse, or maybe the APIs are available but those are not fit for their requirement. So if the API is available, then they can reuse, otherwise they can go for building the new API from scratch. So C4E has a lot of other features where we can see here from architectural point of view, governance point of view, monitoring point of view. So this really adds value to any project. Thank you.